All right. Welcome back, everybody. And thank you, Jasmine. Thank you for supporting us here today. So we have our last workshop of today. Today has been a successful conference. I would like to thank everybody that is actually participating pretty much everywhere, in the villages, at NahamCom, and everybody, especially the speakers, right? So the next workshop is what is under that thing, learning how to reverse engineer an Android app. And without any further ado, I pass it back to Jasmine.
Hey everyone, I'm so glad that you're joining me whatever time zone you're in around the world. So thank you for joining me. So without further ado, let's get started with the workshop. So I guess I should preface how I do my workshops. Half of it will be theoretical where I go over, the topics, and then the final half will be where we do a bit of application. So let's get started. Okay, as Omar said, the title was under that thing, learning how to reverse engineer an Android app. So a little about me. Who am I? Well, I'm a California native, from the Bay Area. I currently live in Charlotte, North Carolina. I have my master's in computer science, a graduate certificate in information security and privacy from the University of North Carolina at Charlotte. My base is in application security, but I'm interested in all aspects of security. And if you want to connect, my handle is thefluffy007 on everything: Twitter, IG, YouTube. I just started a YouTube maybe like a month ago, and I have like one video. So bear with me, I'm building that out. And I also have a blog at thefluffy007.com. So, what is the goal for this presentation? The goal is for participants, you guys, to have a better understanding of mobile security and have the tools to continue further learning. So I just want to level set about, you won't be like a guru, but it will give you the base to continue on in mobile security if you so choose to, and I hope you do. So before we start talking about what's under the hood, let's look at a few mobile security case studies. So from Threat Post, there's the first case study I want to highlight. Financial apps are ripe for exploit via reverse engineering. So as many of you know, with your cell phones or your smartphones, you might have, your banking app like Bank of America, Wells Fargo. Well, white hat hackers found that 30 financial apps that were reverse engineered, sensitive information was exposed. Sensitive information like PII, or personal identifiable information, such as your social, your bank account, all the things that could be tied to you. Also in that study, 97% of Android applications tested lacked binary code protection. So what that meant was that Android applications could be decompiled, or you can look under the hood. And so this is problematic because you can modify these applications, right? As when you reverse engineer, and you can learn the functionality and the logic behind it, you can modify these applications for nefarious reasons. So case study number 2, thousands of dangerous Google apps were found in the Google Play Store. So for Android, the official repository is the Google Play Store. So what was found was there were thousands of dangerous malware apps that were found on the Google Play Store, which again is the official repository for Android apps. And this was done using a neural network to review 1.2 million apps. So what they found was a little over 1,500 counterfeit Android apps had at least 5 dangerous permissions. And we're going to talk about dangerous permissions a little later in this workshop. But to put that in perspective, over 2 billion devices run this mobile operating system every month. So again, even if you're thinking, hey, I'm going to the Google Play Store, that's the official repository, I should be safe. that's not necessarily the case. There are some apps that could slip through the cracks, and you still have to be very careful and vigilant to make sure you are downloading the correct app. And then finally, the last case study was just over a month ago. Google had a patch over a dozen high severity privilege escalation flaws in Android. So the latest bulletin, which was last month, February 2021, 40 vulnerabilities were remediated. So, and these 40 vulnerabilities, Google had to patch an information disclosure flaw, which disclosed sensitive information in the Android runtime. Now, that might not seem, it's like, okay, the Android runtime, why are you highlighting this? Well, the applications and system services use the Android runtime. So essentially, it's any application or any system service could be susceptible to this information disclosure flaw. And again, it had a high severity rating, meaning it had to be fixed pretty quickly. So I showcased this security case study to show even last month, there's still vulnerabilities that come out that still need to be patched and remediated. So again, we have our smartphone devices, and it's so easy to be like, oh, I want to download this app, I want to use it, but you have to be super vigilant to make sure you're downloading the correct thing, because if not, nefarious people could have your data, right? And your smartphone holds a lot of data. It's a mini computer. So I guess the next question, are apps secure? So the answer should be, after looking at this, not really. So I like this diagram from Now Secure, and it pretty much lays out the threat vectors for mobile attacks. And as I said before, your smartphone is a mini computer. So you have really three areas of attack. You have the physical device itself, you have the network, because when you send and receive data, it's using a network. You have the cloud and center, so like a web server, a database. So with mobile devices, you have a much larger attack surface to actually, compromise your device. So you have the browser, you have systems such as Android rooting or iOS jailbreak. We'll talk about the Android rooting in a little bit. With the actual apps, with like reverse engineering, sensitive data storage, escalation of privileges, that network, if for the Wi-Fi, if there's no or weak encryption or fake SSL certificates, the web server, the standard, the OWASP top 10, cross-site scripting, cross-site request forgery, input validation. And then again, databases with like SQL injection, which is part of the OWASP top 10, and things of that nature. So you may be wondering, okay, why Android? Well, Android devices are severely fragmented, meaning that a Galaxy phone will not have the same functionality as a Note, right? Also, Android is open, and mobile providers most times add custom code on top of the Android operating system to make their devices unique. So that's what I mentioned before, like the Galaxy X6 might not have the same code as the Galaxy Note. So this leads to interoperability issues, meaning I could have two devices that have the Android operating system, but if there are custom code on top of one of them, it will not be the same. And it will lead to different results and different outcomes. So that's the thing between Android and, well, some of the things were Android and Apple. With the iOS, for the most part, it's very streamlined. It's like it's, one, user, it's pretty tightly coupled, it's pretty tight. Also, it's not open source. Apple is proprietary. You don't have the source code. It's not open source. It's owned by Apple. So in that regard, iOS is very, tightly coupled. I'm just to the quick caveat, I have not done iOS. If you have, I would love to talk with you. All of my stuff has been in Android. So where do you get Android apps? So as I mentioned before, the Google Play Store, which is the official repository for Android apps, but there are other sites like APK Mirror, APK Pure, and Aptoid. I put stars here because you should use these sites at your own risk. Again, the Google Play Store is the official repository. But for instance, if you are, wanting to test an application and for whatever reason you're not finding it on the Play Store, or you're just like, I just can't find it, or the wrong version, whatever, and you find it from these other sites, again, just use it at your own risk, right? Because again, malicious apps, counterfeit apps could be there. So rooting. So in Android, it allows for a small subset of applications to run with root privileges. So the Android operating system uses the Linux file system, and with Linux, you have a user, which is root, which is like the super user, which can do anything in the system, right? So Android has the same concept where the root user pretty much has the keys to the kingdom. And so when you are root, Android operating system does not stop the application to modify the operating system, the kernel, or other applications. So when you're root, you have full access to applications, data on the device. As I said, you have keys to the kingdom. So also when you allow your applications to run as root, you increase the threat exposure on your device for malicious applications and application flaws. So again, you should very sparingly, almost never have your apps run as root. That should be like a special case. And most times, like if you have an app and you download it from the Google Play Store and it's like, hey, we want to run as administrator or super user or or root, you should definitely deny. You should not give them access, because if you do, then essentially that app can do anything on your smartphone. It can, delete data, it can add data, it can do anything. So in that case, you want to be very, very careful. So we're going to talk about components of an Android app. So there are 4 components: an activity, a service, a content provider, and broadcast receivers. So let's get started. So an activity, it represents a single screen with a user interface. So this is similar to a window in a desktop application. And so an Android app can have one or more activities. Now, in an Android app, where we will see later, every app has a main activity. And that main activity is the entry point to the application. So if you have an Android app and you do not see a main activity, it will not work. So that's, one of the rules for Android is you need to have a main activity. Next, services, and I've broken them down into 3 different services. So the first is the foreground service. So this is where users can interact with the service by notifications of an ongoing task. So an example of this is when you're downloading a file on your smartphone. You download a file, you can see, the percentage done, you can stop it, you can pause it. This is a task you can actually interact with. This is a service you can interact with. A background service is, no user interaction. So again, the services do not notify the user of ongoing tasks, or you can't interact with it. So an example of this is like syncing data, right? If you have like a Gmail or email app on your phone and it's syncing between your smartphone and the server, you might see a dialog box that says syncing data, but you can't stop it, you can't pause it. you just, that's a background service because you really can't interact with it. You see it, but you can't do anything with it. And then finally, bound services. And these are services that perform their tasks as long as the application is bound to it. So for instance, if I have an application and it's bound to the operating system for 10 minutes, then that is a bound service that is bounded for 10 minutes. And then once it's done, it's unbounded. It's not bound anymore. Content providers. This supplies data from one application to others on request. And you can think of a content provider as a centralized place of content, and it allows different applications to access it. So if you look to the right of this slide, you will see different apps, 3 apps. You will see the content provider is in the middle, and then you will see like different, like the internet, a database, SQL files, and you will see that you can read and write, and the content provider is like the middleman between the apps and the data layer. So it's like the middle layer of saying, hey, okay, all of you apps come to me, then I will interact with the things you want to do, and then it will go back and forth that way. Finally, broadcast receivers. These receivers respond to system-wide broadcast announcements. And so, for instance, these are messages are called events or intents. So, and some examples of this is, when the screen has turned off, we turn off the screen, or when it goes to sleep, and low battery. So, as you can see, the broadcast receiver registers intents to be observed to the Android operating system, and then the Android operating system gets notifications when the intents occur. So it's more so of a circle pattern. So Android x86. So this is an emulator. I have this on my SourceForge site that I put in the Discord, the Red Team Discord. So I should say, when you're doing Android hacking, you should probably have an actual physical device. But for this workshop and, for you to get started, I have included an emulator for you to start testing things out, until you get an actual device. So this emulator can be used to test applications. The current release is based on Oreo. Some common features are Bluetooth, Wi-Fi support with GUI, debug mode with BusyBox. You can also log into a Gmail account. This is important. Again, if you want to download apps from the Google Play Store, you would need to have an official Gmail account to do that. But if you do that on this emulator, I would suggest to create a test account and use this test account to download applications. I will not use my real email. I'll just use that as a quick caveat. So, intro to Android Security Virtual Machine. So this is a virtual machine that I created that has the common Android hacking tools that you need. It is based and built upon Ubuntu 18.04, Bionic Beaver. It was also inspired by Android Tamer, which is another Android hacking tool that has common Android tools in a virtual machine. So I was heavily inspired by that. So show them some love on Twitter. And some tools that are in the virtual machine are manual dynamic analysis, penetration testing, reporting, and reverse engineering. So now let's start talking about some of the tools. So APK tool, what is it? Well, it's a reverse engineering third-party tool that you can use to reverse engineer apps, and you can decode resources to close to their original form. And you can also rebuild applications after modification. And once you actually decompile an Android app or Android package, that's what APK stand for, you would get four different items: Smiley, Res, MetaInf, and Android manifest.xml. And I will talk about all of these in a second. So if you look to the right of this slide, you will see like APK tool D. The D is for decompile, and then you specify the actual Android app. Android apps and in .apk or Android package. And you will see that it's actually decompiling this app. So Smiley, what is it? So it's an assembly language used by the Android Dalvik virtual machine. So assembly language for most people. So assembly language is used in computers. So like in your interpreted language, or excuse me, your high level languages like Java, .NET, all of these things can be broken down into assembly language, which is like the low level, bare bones of programming languages. You could program in assembly. I wouldn't recommend it. I haven't done it in over 15 years. I did it when I was in undergrad, for a course. Most times you really don't program in assembly. And if you do, hey, all power to you. So Smiley is similar to that for Android because it is like the bare bones of an Android app. And it is the workhorse of Android apps. It's decompiled to a .dex, which is Dalvik executable. And again, it's used for low-level inspection of Android app content. So you can look to the right of this slide and you can see kind of like the bare bones. We see like line 104, we see, line 354 if equal to 0, and you're checking like a V13 and it goes to like condition 0. As you can see, it is very low level, like it's low level. I should also specify that Android apps are written in Java. So again, this is when you look at an Android app, you will see it in Java, but the Smiley is like the bare bones of that Java. And this is an example of that. So Res, this is a folder for additional files and static content. Things you would have are images, layout definitions, user interface strings, and animation strings. And these are all in relation to the Android app. So everything that's more so visual for the Android app, you will see that in this folder, the Res folder. And if you look to the right of this slide, you will see an Android app, and you will see like the main activity, which I mentioned every Android app has a main activity, and you will see that it's also written in Java. So that, to the right, this is Java code. So MetaInf, this folder has three contents in it. So cert RSA is the first, and it contains the signed contents of the cert SF. So this is signed with the developer's public key, the private key, and the public key is used to verify the signature. So cryptography is a little bit outside of this course, but there are two facets of cryptography. You either have symmetric cryptography, where you have one key between the sender and the receiver, or you have asymmetric cryptography, and where you have pairs, where each pair has a public and private. And as the private specifies, only you should know that. You never private. So in this case, what happens is the developer signs with their private key, and then the receiver will then verify with the public key. And if the developer will sign with their private key, and then the receiver would then use the developer's public key to get the original contents. So that's how that works. And why you want to sign with the private key with code signing, it's additional layer to verify your contents, also make sure it's not being modified or compromised. Cert SF is a list of all the files with their SHA-1 hash. And with the hash, it's a one-way function, meaning you can complete a hash, but you can't go back to its original form. And again, that is used for entry purposes to make sure that your files have not been manipulated. And then the manifest.mf, which contains information of the application, such as package version, build number, creator of the package, etc. So to the right, we have, a folder that shows the 3 different files that I just described in the meta.inf folder. Next is the Android manifest, and this is located at the root of the project. Just like with a main activity, every Android app has an Android manifest. And you can think of the Android manifest as a skeleton of the app. It pretty much describes everything about the app. So the manifest declares the app's components, such as the components of the application we talked about: activities, services, broadcast receivers, and content providers. It also talks about permissions the application can use for APIs or application programming interfaces. It describes the permissions that the app has. It also declares the minimum level of Android that the application requires. So in this case, if you look to the right, we see here that a manifest, and it's pretty much a basic standard manifest. As you can see on line 6, we have the application line. It talks about the activity, and inside of the activity in line 9, we have an intent filter inside of it. And then in line 16, we have a uses SDK, min SDK version of 2. So this application can use any level of the Android operating system. It's pretty much the first Android operating system. So again, with the min SDK version, it will be a number. So you won't see like Android 9.0. You will see the actual numeric equivalent of that. So like SDK version 42, I'm making that up. And then you could correspond that with the operating system that it will use. So as I mentioned before, permissions. So normal permissions, these permissions do not pose a to users' privacy or device operation. And the system automatically grants these permissions to your app because, the Android operating system sees these permissions and it's like, oh, yes, this is fine. These apps will not hurt me. Oh, yes, I approve you. No problems. So some examples of normal permissions are like Bluetooth, change network state, disable keyboard, get package size, internet. It's like, okay, we have decided these are normal permissions that are not here to hurt. So yes, I approve. Next are dangerous permissions. And remember, in the second case study, I mentioned about that, with the counterfeit apps, it found that there were at least 5 dangerous permissions. So these permissions could potentially affect the user's privacy or the normal operation of your device. So when an app is using a dangerous permission, your phone or you will be notified to say, hey, do you want to use, or do you want to use this? And I'm going to show an example in a little bit. But some dangerous permissions are read calendar, write calendar, read contacts, write contacts, record audio, read phone state, call phone. These are all the things that could change the normal operation of your device or privacy. So unlike normal permissions where the operating system is like, okay, yeah, I approve you, this is fine. With dangerous permissions, the phone is like, whoa, I see these permissions here. This can change my state. I'm going to present a dialog box and it's like, hey, do you approve this? And if you say yes, it's like, okay, well, that's fine. You know, I'll grant you access and you can keep going, but I'm going to alert you. So for this, for Android devices running Android 5.1.1 or lower, the system will ask this at installation. So when you install an app and you're like, hey, install, and then a pop-up will come up and it's like, this app wants to view your contacts and look at location and microphone. Do you accept? Almost like this, the screenshot on the right of the slide. It's like, hey, do you accept? And if you say, you press the accept button, then it's like, okay, well, you're aware of the challenges or the things that could go wrong and you accept it, so I'm going to keep going. Now, for Android devices that are running 6.0 or higher, it will not prompt you at install time, but rather at runtime. So what happens is for later versions of Android, you press the install, it installs perfectly, no problems. But when you click to actually run the application, and that's what runtime means, when you click to say run, then a dialogue will come up and it's like, hey, you know, this app wants to look at your, you know, your pictures and record audio. Are you sure about this? And again, like the screen right, it gives you an allow or a deny. And if you say deny, depending on how the application is set up and the permission, if you click deny, the application might not run. It might just quit altogether. It might be like, oh, this permission is needed to execute this application, you know, quitting, right? Most times, if you say deny, it, you know, the app for the most part will still run, but that functionality will be turned off. And again, you know, I'm just going to keep specifying this. Be very cognizant and very active on the permissions that your applications need. So as I said before, if you have an application and it's an application that changes colors, and it's like, yeah, I need to access your contacts, you know, I need to access your phone. You know, that should be raising a red flag because it's like, okay, this app is just changing colors. Why do you need my phone to change colors? Like, you don't need that, right? So again, you have to be very cognizant of what the app is trying to do. And I know for most people, they just get an app and they're just like, install, allow, without really looking at what's going on, what they're actually allowing onto their phone. So the next set that I'm going to explain is, you know, what we all want to do, which is reverse engineer an app. So in this case, what we have is JADX GUI. There's also JADLI, which is the command line. And again, it depends on your flavor. And it's a DEX or Dalvik executable to Java decompiler. As I said, Android apps are written in Java. And in this case, the GUI is a tool to produce Java source code from Android DEX and APK files. So APK or Android package files, which are Android applications. So to the right here, we see, you know, we have actually decompiled an application and we're looking at the source code. We're actually looking at the source code of an application. So you're like, ooh, okay, I'll use the JADX GUI and I'm in there like swimwear. Well, not so fast. For most applications, they're going to make it hard for you. So for instance, if I'm a developer and I'm like, developer, I don't want you to look at the logic of my application, right? So I'm going to use a concept called obfuscation. And so that is the process of trying to make in this case, code, obscure, unclear, or unintelligible. And so most of you, or some of you, have heard the concept of security through obscurity, right? So this is what it's doing. So it's like, hey, I have my nice code and I'm going to put it in jumble words that are like unclear and unintelligible, because in my mind, that is going to, thwart you, and you're not going to want to figure out the logic of my code. There are tools to de-obfuscate to the original code, and one such tool is ProGuard. Also, if you don't have ProGuard, what most people do is they'll just look at the code and kind of like piece it together. And that's what we're going to do in our case. So it's like, even with reverse engineering, most times you'll look at the source code and it's like, wow, this is like gibberish. And that is done intentionally, because it's like, I don't want you to know the functionality of my code, because at that point, you can change it, right? For instance, if I have an app and, let's just say Facebook, and it's, you decompile the app and you look and it's like, hey, the server, this should never be in there, but, the server for the, username and password, the login credentials, it's this specific server. Well, if I know that, I can change it from Facebook servers to my own servers. And then I could rebuild the application and push it back to the Google Play Store. And then when people download that app, they put in their username and password, they put in their credentials, thinking they're getting into Facebook, but they're really sending it to your server. So then you have effectively captured username passwords that you can then use for nefarious purposes, right? So a way that developers try to mitigate against this is to use obfuscation, because in their mind, they're thinking, okay, if I make it unintelligible and, like gibberish, no one is really going to spend time actually try to piece it together. But that's not the case. So next, Android Debug Bridge, ADB. So this is a client server program, and it's used to connect. We're going to use it for our emulator, but if you actually have an Android device, you can use a USB from like the phone to your computer and use it that way. And it's a client server program that has the following components: a client, which sends commands to the device, daemon that runs commands to on the device, and this is in the background, a server that manages communication from client and daemon, and this also runs in the background. So on the right here, we see ADB connect, and what this is saying is, hey, we have a device and we're saying, hey, connect to this device, and we provide the IP address. And then the next command, ADB devices, it shows that, okay, it has connected successfully. And for ADB, the port is 5555. So common ADB commands: ADB connect, which we just shown, ADB devices, -L, that's a lowercase l, queries the list of attached devices. ADB start server, it starts the ADB service. ADB kill server, and again, this kills the ADB service. ADB install, this installs an application to the device. ADB logcat, we use this to dump system log. ADB push, this is used to copy files, directory and subdirectories to the device. And ADB pull is sending from the device to your computer. So Frida is a dynamic code instrumentation toolkit, and you can modify logic in mobile devices while it's running. So Frida is considered dynamic analysis. So for instance, you might have an application and you click on it and it's like, hey, you're root. I'm closing. You can't do anything because you're trying to run as a super user and I'm not going to allow you. to do that. So what you can do is you can use Frida, hook into Frida. And again, this is where the reverse engineering comes in, find the logic of where, it's doing the for root or super user, and then you can write code. And again, Frida uses JavaScript, Python, C, Swift, and .NET, as well as other languages. And you can write a nice little script and inject that into Frida and then re-execute the program to mitigate and bypass those checks. So Frida is a dynamic code analysis tool. Again, Frida is so powerful that I have sites at the end for us to for you to look for after this course, after this workshop, to continue on with your learning. One of those is Frida, because there's so much you can do with that, like to bypass things and, do all the things I will not be doing it justice in this workshop. Next is MobiSF. And this is the mobile security framework. And so this is an open source intelligent tool that can be used to perform static and dynamic analysis on both Android and iOS platforms. So it also has web API functionality to do information gathering, analyze security headers, also look for vulnerabilities such as XXE, XML entity, or SSRF, server-side request forgery. So if you look to the right, here is a screenshot of MobiSF. And as you can see here, it lists the 4 different components that I talked about: the activities, the services, the receivers, and the providers. And it gives us a good information about an Android application. So for instance, if you're under the gun and you're like, hey, I just want a quick snapshot of what this application can do, you can put it into MobiSF, and then it will give you, the basics, and then you can go from there. So in summary, attack vectors are wider in mobile apps. The barrier to entry is pretty low in Android because it's open source, and you can reverse engineer these apps. And, you can do that to look under the hood. As I mentioned before, Frida is a good tool to use for dynamic analysis because you can change logic on the fly and bypass checks that, developers have put in, like, haha, I got you. And it's like, no, bypass that. And then also, there's no silver bullet with mobile security. So what might work in one instance, like one Android device, will not work in the other because, again, due to interoperability issues, there might be custom code in one that's not in the other. So again, every Android device is, you should really treat it as a case-by-case basis. So for continued learning, inside of my Intro to Android Security Virtual Machine, I have included some apps for you to play with. MSTG Hack and Grant is the mobile security testing guide from OWASP, Open Web Application Security Project. That is their app to play with. Also Diva, IG Learner, and the Uncrackable series, and there's levels 1, 2, 3, and 4. Level 4 has 2 apps, and it's the R2 Pay, and both of those apps are for level 4. And so what you can do is you can push these apps to the Android emulator using the Android Debug Bridge, or ADB install command. And then here of the additional learning, I've included HackerOne. They have a playlist. F, it means free, so you don't have to pay. There's also some more challenges. So MobiSec is also free. And then Pentester Lab has Android challenges, but you have to pay for those. Suggested reading, just more on the Android fundamentals, JavaScript, Java, or Python. Again, you don't need to be, a guru at this, but if you know how to read especially with Java or Python, because you can use that with Frida. If you can read and then do basic things in it, you'll be great. Java, again, because Android apps are written in Java. So if you know Java to the point that you can read and kind of deduce what's going on, that will be good. The Android debug bridge to learn more about that, and Frida, which is the dynamic analysis tool. So now what we're going to do is I am going to go to our application portion. I'm going to open the Android intro to Android security. The current version is 2.0.1. I'm going to open that, and I'm also going to open our emulator.
Hey, Jasmine, just one quick question. Sorry to
Yeah.
interrupt you. So we had a question in Twitch, and I think in a couple of places on where the Android x86 link, the external link to a Google Drive is not working. I think that you have to change the permissions so they can follow along.
Oh, okay, darn.
Yeah.
I thought it was working. Okay.
Probably do it after the.
Yeah,
after
I'll
the
do it after. I'm so sorry. I thought it was working. Darn. Okay.
No worries. No worries.
Okay, sorry, y'all. That, yeah, my bad. Okay, so I want to see if I can put these side by side. Hopefully the demo guys are with me today. Okay, so for the Android intro to Android security, the username is Android. The password is security, lowercase. And I should also mention that for the emulator, it takes a lot of memory. So right now I have 4 gigs for just this emulator because it takes a lot. So just be mindful of that. So if you use like a few gigs, it will go very slow. And again, as you can see, I have 4 and it's still not as fast as I would like. It's okay. So I just want to make that be known that the emulator uses a lot of memory. So while we're waiting for the Android emulator to load, what I can do, so my intro to Android security VM is to the left here, and I'm trying to have them side by side, so excuse me for that. So I opened the Android home folder, and if we go to documents, here is the apps that I had listed. Now, disable root and disable root 2, you will not have those files. That was something that I did when I saw the first level of the Uncrackable challenge on my YouTube. So you will not have these 2 files, but everything else you would have. Okay, for the Android emulator, there will be times where it's like the system UI isn't responding. So what you can do is click on wait, and then it will come up. Okay, and as you can see, the tablet is starting, so the emulator is starting. Okay, wait again. Sometimes it can take a while. Okay. So what I'm going to do here is, now what we're going to need to do first from our emulator is we need to go to go to the terminal emulator. loading, I promise. As I said, this takes a lot of memory. So I'm trying to wait for this to load. Because I feel like, okay, it's about to load. So I feel like if I go and talk about the what I want to talk about in the intro to Android for security is going to load. So it's loaded now. So what we're going to type is ifconfig. And what we want is the WLAN 0. We want this IP address. In this case, for mine, it's 192.168.1.92, because what we're going to do here is we are going to click on menu and type terminal and click that. And what we're going to say is ADB connect. And we're going to use that IP address, 192.168.1.92. So now we have successfully connected to our emulator. So now these two virtual machines are talking to each other. So I have already installed the app that we're going to use, but I'm gonna do it again. So to show you guys, so what I'm going to do is I'm going to go to the download documents directory, and I'm going to do a ls-la. So what that says is a long listing showing everything, including hidden files, and hidden files are designated with the period before. So what I'm going to do is I am going to bring the iglearner.apk. So what I'm going to say is adb install iglearner.apk, and I'm going to press enter. Okay. And we should get a success to show that it installed properly onto our device. Yes, we did. So if we go back to our emulator here and we click the 6 dots, we see here IG Learner. It has successfully installed. So we have successfully installed onto our emulator. And again, it will be the same thing if you actually had a device, except you would have a USB cable from the device to your computer. And it will be the same thing, ADB install. So now what we're going to do the first lesson, and I'm going to try to make this bigger. Okay, thank you. And if I click on lesson 1, let's see instructions. Okay, I'm trying to make this bigger. Bear with me, you guys. Okay, the secret code is lurking somewhere in there. Find it, and when ready, enter the code in the provided box and press the submit button to see if you're correct. So we need to find a secret code. Okay, so now we're going to reverse engineer an app. So going back to our intro to Android security, virtual machine, we're going to click on menu. We're going to go to reverse engineering, and we're going to click on JADX GUI, because I like working with the GUI as opposed to the command line. But again, it's your flavor, what you want to do. You click on that, and it should open. Yes, it opens, and it's like, okay, what do you want to open? So we want to open the IG Learner APK. Okay, so now if we click on, we have inside of the comment reputusgroup.learner. So this is a package, and this is a Java term. This is a package, and then these are files under that package. So again, we want to go to lesson 1 activity. So I want to make this bigger here. So we are now looking at the source code for this activity here. As I said before, Android apps are written in Java. And if we scroll down, we see on create, we see things that are being done. Now, we also see this challenge, generate challenge. We see a field log with garbage. We also see lesson 1 on submit. So scrolling down, this is where the reverse engineering comes in, because now we have the code. We need to see what the app, in this case, what this lesson actually does. So we see a generate challenge, and we see we're doing like some randomness with the alphabets. And, we're doing, some randomization. But if you scroll down to field log with garbage, we see here that we have this log of learner here. And if we scroll, we see learner and we see string value of, and then we have, generate challenge, and then this dot challenge. So it seems like we're going to have to look at the logs to get our string. So what we can do, so if I scroll here, okay, so we know we have this learner. So remember, inside of ADB, we have an ADB log, and I believe it's log cat. So what we can do is we can go back here and we can say ADB log cat learner. Okay, and then I want to grep for learner. So now it's just waiting. So let's see if I type test and press submit. Okay, that was not the correct answer. Okay, I think I'm using ADB in the, oh, okay. So I did, okay, so did I close this to, okay. Hold on, let me. Okay, I want to maximize this. Okay, so we see here, okay, it's giving us learner, but it's not giving us what we want. So let's go back here, and it's like, okay, let me, okay, that's why I said I hope the demo guys is with me. So let's see if I say ADB log cat grep. Okay, let me try to type test again. Okay, that's not correct. Okay. Enter if I stop that. Because here, what should happen is I should get the correct, oh, sorry. There was something that I missed. So here, inside of the lesson 1 on submit, we see check log string. And so if we go here, it's like, hey, does the string to test equals this challenge. So if we look inside of field log with garbage, we see here that the first is this dot challenge. So it's saying, hey, you know, this is what we want to execute because that will point us to the correct value. But let me go back to my slides very quickly because it's like, I don't think I'm using the ADB log. Okay, ADB log cat. I don't know if that's what I was typing. No, that is what I was typing. Okay. So ADB. Okay, so it is logging. So say okay, that's what I'm typing. So say ADB. Not correct. Okay, so what I'm going to do now, because I don't know what is going on, and I kind of figured that was going to happen. So what I'm going to do now, I will provide updates on that. I will go to lesson 3. I don't know what's going on with my log, why it's not coming up. So let me try lesson 3, if this will come up. Okay, so what I'm going to do now is I'm going to go to lesson 3 activity. And so here we kind of have some of the same things. And if we scroll, we see here, we have a lesson 3 on submit, click, and it's saying try file Android assets test.html. And it's saying, hey, okay, we're going to try this. And if it doesn't work, we're going to output an error with a log. So let me wait. So here, if we have IG Learner, and if I click request URI, it shouldn't work. I should be getting an error. What is going? Okay. This. Okay, because it should be giving me like incorrect. Like this should be red and it should be incorrect, and it's not doing that. Okay, I kind of figured this was going to happen during the demo. Because essentially what we want to do is okay, so click me. This is what I was waiting for. Click me to see what happens. So locked, right? So we need to unlock it. And so if we go back, and if we, okay, I went back too far. And if we said, And if we tried, let's see. Okay, so this is what I was looking for. So in the lesson 3 handler activity, you see the unlock key is crazy URI handler. So here it's saying, hey, if the path contains crazy URI handler, then we're going to use that to unlock. So let's change this to, instead of test me, to crazy URI handler and say request URI. Okay. See, we solved the challenge. Okay. Oh, okay. One, I need to go back and see what's going on with lesson 1. So let me explain what happened. So we had lesson 3 activity. And again, Android app, it has an activity. So this will be the main activity. So I looked here and I didn't see what I was looking for. So I saw, some things like on back press, finished, lesson 3 on submit, click. And, it tried loading this URI. And then if there was an error, it would do a log. But then I was like looking to the left, I see that there was another activity for lesson 3. So clicking on that, we see an unlock key. And remember, when we first pressed the, click me to see what happens, we got a red locked. It was like, hey, locked, you can't go any further. So now looking at this lesson 3 handler activity, we see, hey, this is the string we need to actually unlock this challenge. Crazy URI handler. And when we put that inside of our URI and then pressed request URI, I'm gonna do it again. And we said, click this request URI. And then it's like, hey, click me, see what happens. And we have successfully completed the challenge because we have unlocked it. So this is an example of reverse engineering an application, because again, we're looking at the source code for this lesson, lesson 3. We're looking at it, for the most part, this really isn't too obfuscated. You could kind of follow along. There are other, like I know for the uncrackable challenges, if you do that, that is obfuscated and you kind of have to do piece by piece. And so again, this isn't too obfuscated, so you can look and it's like, okay, it's doing, it's looking for submit, it's doing backs, and it's like, okay, but I really don't see what I'm looking for in this file. So going to the second, it's like, it's locking me, so I need to unlock it. And it's like, oh, hey, you have the unlock key hard coded inside of your application. So if this was a real application, like on the Play Store, you wouldn't to do this here. This is a no-no with actually hard coding. Again, this app, the IG Learner app, as it, as the name, specifies, is for you to learn, right? So again, you will be surprised when you look at real apps where they'll hard code things, because again, they'll think, no one's is really going to reverse engineer this and look at my code. No, don't do that. So this is a big no-no, but in our case, this works because this is a workshop. So we have the unlock key, and then if we scroll down, we'll look down, we have an on create, and it's like, hey, we have, let's get the intent, we have the URI string, and we get the path, right? And then it says, hey, if the path, this is a conditional. So it's like, hey, the path that we just constructed in line 29, if it contains crazy URI handler, our unlock key, if it contains that, hey, just unlock it, just unlock the challenge. We've solved it. So that's what that says here. The lock status set text is to the unlock string. And that's what we did there. So this is a quick example of reverse engineering an app, looking at the code to figure out what it does. Now, remember I mentioned resources, right? And I mentioned like the res, the Android manifest, and all of the things. So if we click on Android manifest, this one is pretty big because it has all of the lessons here. So you see that, for permissions here, it says read phone state, we have internet. You see that the Mint SDK version is 14, the target is 16. So again, we're seeing, okay, for this application, these are the minimum SDK version is 14. We see here, we have, lesson 2, it points to the activity. And it's like, okay, hey, these are the activities that we need. So again, as I mentioned before, the manifest is the skeleton of an Android app, and it specifies pretty much, how your app is going to flow. And then we have the meta inf, and here for the manifest.mf, as I said, here are the SHA-1 hashes. And again, this is used for integrity purposes to make sure it hasn't been altered. But now, let's see if this will work. So remember, I mentioned MobiSF, right? So if I go here, also let me describe how this works. So for the MobiSF, first, what you would need to do is start the server, and the password is security, lowercase. So it's in a Docker container. So we're going to start Docker, and it's like now starting MobiSF. And again, like if you're like, hey, I need to look at this Android app and I really don't have a lot of time, you can use this. It's a good app that has like dynamic and static analysis. And it's loading. And I'm trying to wait till it's done so I can bring it up. Okay, so now it has started, because once you see booting worker with PID, with process ID, now you know it's working. Let's see if I start the UI. This will work. Okay, so inside of the intro to Android security VM, I try to make it as painless as possible for you. So it's like you start the server and then you can start the UI. So it's like, it's pretty much just click. Okay, so next what we can do is we can pick, let's just say I'm going to pick, okay, I don't want to make that big. I'm going to pick the crackable. level 1. And I'm going to down, you can drop it anywhere. So now it's analyzing. I just want to show you how MobF works, how it works when you use it. So it's analyzing. Please give it a little bit of time. While it's analyzing, I should say, since we are in a virtual machine and it is using Docker, the dynamic analysis portion of MobSF does not work. It doesn't work in a virtual machine and it doesn't work in a Docker container. So let me specify that quick caveat. So it's like, hey, I want to do dynamic analysis. You won't be able to do it inside of the virtual machine. You would need to set up MobSF on your actual physical machine if you want to do dynamic analysis. You can't do it in a virtual machine or a Docker container. So I want to specify that. So as you can see, it pretty much has gleaned a lot of the data for us. So for instance, the average CVSS score, 7.5, secure 90 out of 100. It gave us the name, the package, the main activity. Remember, every Android app has a main activity. It gave us the target and minimum SDKs for it to work. If we scroll down, we see we have 1 activity, 0 services, 0 receivers, 0 providers. And again, so the dynamic analysis, excuse me, because I am in a virtual machine and it's also in Docker. So if you use this virtual machine, the dynamic analysis portion will not work. And I just keep mentioning that because it's like, I don't want people to try and it's like, hey, it's not working. That's why. So we can look at the manifest, we can look at the source code, the Smiley, and here it's giving us information. And then if we scroll down, it's like a warning, this is application is signed with version 1 signature scheme, and it's making it vulnerable to the Janus vulnerability on Android less than 7.0. And then we can see, it gives us a lot of information, and it's like, hey, application data can be backed up. So again, I'm just showing this. I'm showing this. So if you're like, hey, I have an app, I don't have a lot of time, but I need to get like a baseline, of some things that it can do, and then I can do research from there. MobSF is a good tool to just dump it into to kind of see what it returns. And then, you can go from there. So again, the app may request root or super user privileges. And then it gives, the rating. App logs information, sensitive information should never be logged. So again, MobSF is a really cool tool to use. And again, you have, all of these things on the side, like malware analysis, reconnaissance, and things of that nature. So one final thing, because we got less than 10 minutes, I mentioned the APK tool, right? So let me open another terminal or another tab. And I'm going to go to documents. And what I'm going to do is I'm going to say APK tool D, and I'm going to do the uncrackable level 1. So what I'm saying is, hey, decompile this uncrackable level 1 Android app. I'm going to press enter. And as you can see, it's actually decompiling. So for instance, if we didn't have the JADX GUI on this virtual machine, you can actually use the APK tool to decompile. And then if we go back to the documents folder, we now have the APK, the uncrackable level 1. And now we could actually, where is it? Okay, that's the Smiley. but we can actually look at the code this way. So again, it's more so picking your poison. I like the JADX here because it's a nice way to look at everything. And then, I don't need to decompile anything. All I need to do is just open, JADX GUI, point it to the Android app. It does all of the decompiling for me and actually shows the Java code. So it's kind of like a one-stop shop. So I would say before using mob SF, it would be good, if you looked at JADX GUI on your own, actually look at it yourself, even if you spend like 10 to 15 minutes, just look at everything, look under the hood yourself before looking at a tool. I mean, just my personal preference is I would like, knowing what's going on under the hood using tool, right? Because the tool is great, but it's just great to kind of like second guess because there might be things the tool doesn't find that you find, with looking at it with your own two eyes. So we have 8 minutes left. I guess this will be a good stopping point for me for this workshop. And again, sorry about lesson 1. I don't know what happened with the demo gods with that, but I did show it with lesson 3. Reverse engineering, it was locked, finding the unlocked key, even though you would not want to have that in app because that would be considered like a hard-coded password of sorts because essentially it unlocks this this activity. So you really wouldn't want to do that. I guess if there are any questions, Omar, I could take them. I know that I need to change the permissions for the Android x86 after this workshop. Sorry about that. I thought it was correct beforehand. So again, sorry, I would definitely change that. But I guess we got 7 minutes left. So if there are any questions.
One question
Yeah.
that came in through Twitch that I saw, and it was a little earlier. Will apps written in Kotlin decompile to Java?
That is a good question. Let me get back to you on that because I don't want to give an answer and it's not correct. A part of me wants to say yes, but I also know that some apps, it's Java, but then some libraries might be in C and C++. So let me get back to you on that because I don't want to give you the wrong answer.
Okay, no problem. Yeah, I think the answer is probably not, but I'll let you.
Yeah.
And let's see if you have any questions. There's a couple of seconds of delay between where we open for Q&A and you're able to answer or you're able to see the questions or vice versa. Let me check on Discord.
Are the questions inside the Discord? Because I
don't see any questions in the Discord server or Red Team Village. Let me check because we have so many. Let me.
I know. Yeah, I just want to. If there are some questions, I just.
The only other one was earlier today. Will your slides be available?
Yes, my slides will be available. I will have it on my site, the Fluffy 007, and I'll post it on. I will send a tweet when it's available.
Okay, perfect. And then I'll put in the Discord server.
Yeah.
Awesome. Yeah, I think those are. Okay, there's one more. Says I have a question. Like when an API disclosure has information leaks, how the impact will be? Let me see if I can paraphrase that in the Java code. I mean.
Okay, the impact. That's why I kind of wanted to show the first exercise that didn't work. I mean, it depends on what's being leaked, right? So for instance, if you were leaking, let's say bank account information or social security numbers, the impact of that would be very high, right? Because that's personal identifiable information. So then, it depends on what is being leaked. I hope that answers the question, unless there's something else.
I think that was the question. And if not, they will probably type it in a few seconds.
Yeah.
It's about 40-second delay between whenever we talk and they can see it. But yeah, I'm monitoring here.
Okay. Yeah, I just want to be respectful because I know we got like 4 minutes left before the ending. So I kind of wanted to take a few questions, but also wanted to be respectful for people who wanted to go to the closing ceremonies.
Oh, that no worries. We're not overlapping with that. So
okay, cool. Okay.
We have all the time. Now there's another question coming in. How accurate are the analysis with tools like MobSF or Cuckoo Sandbox?
Okay, so MobSF recently went through a major upgrade. They're also on GitHub. So for the most part, I know this tool updates pretty regularly. So I know they did a major upgrade like this year, like earlier this year. And again, they have Twitter. I know they have a Twitter account and they usually announce they will do upgrades. Most of the tools that I have inside of the virtual machine have GitHubs. And then for the most part, most of them are updated regularly. Some of them not. It might be infrequent, but for the most part, a lot of them are updated pretty regularly.
Yeah, it actually looks like MobSF was updated a couple of weeks ago.
Yeah, so they're really good. Actually, the gentleman Anant, who is the creator of Android Tamer, that was the inspiration for my virtual machine. He actually is a part of MobSF. So he like does testing, and I think he provides functionality and things of that nature. So yeah, they update regularly, pretty regularly.
And then one last question from Zaid NZ. It says, you mentioned that MobSF dynamic only works on actual devices, not on VMs. Can you clarify on that?
Yes. So if you look on their GitHub, it doesn't work inside of virtual machines and or Docker containers. So I'm using a virtual machine. This is a virtual machine here. It will not work. Also, inside of the virtual machine, the MobSF application is inside of a Docker container. So on their GitHub, they explicitly wrote if you're using our program inside of a virtual machine or a Docker container, the dynamic analysis doesn't work. Like the functionality doesn't work. So you will actually have to download the MobSF application on your physical computer if you want to use the dynamic analysis. So that was something that they called out on their GitHub.
Perfect. And I think that's it. Those are all the questions that I see. Thank you so much. I really appreciate your time. Thank you for supporting the Red Team Village, the whole
thank you. And again, sorry for the lesson one. The demo guys were somewhat with me here. They weren't with me all the way. But again, I hope everyone has learned a lot. I will provide the slides. I will do the updates for the Android x86. I also have a walkthrough to get everything set up. So again, I hope you guys continue on your learning with mobile security and have a good day or night wherever you are. Thank you again.